And here we hit a curious gap in scale. There are lots of black holes up to 150 solar masses, and then there's nothing for a long time. Until we suddenly hit black holes that are millions of times more massive. Which is a bit confusing because we had this idea that black holes are consistently growing and growing. But for the most massive black holes, this process is not fast enough to explain their existence today. The universe is simply not old enough for these supermassive black holes to have formed by eating stars and merging with each other. Something else must have happened. To explain how we got the largest black holes in the universe, we might need the largest stars that ever existed, quasi-stars. To get a sense of scale, we can compare them to the largest stars that exist today. Our Sun is like a grain of sand next to them. We don't know if quasi-stars actually existed, but they're an interesting concept when it comes to supercharging black hole development. The idea is that the matter in the early universe was so dense that quasi-stars could grow to thousands of times the mass of our Sun.
You want to understand the universe, Floki?
Stars might have been crushed by their own weight so much to actually collapse into black holes while the star was still forming. In contrast to stars today that would destroy themselves in the process, inside quasi-stars, a deadly balance could emerge. Gravity pressed the supermassive star together, feeding the black hole and heating the material falling in to such a degree that the radiation pressure kept the star stable. And so these quickly growing black holes might have been able to consume the quasi-star for millions of years and grow far bigger than any modern stellar black hole. Black holes several thousand times the mass of the Sun and wider than the entire Earth. These black holes might have become the seeds for supermassive black holes. So now we arrive at the kings of our universe, the largest single bodies in existence. The centers of most galaxies contain a supermassive black hole, and they are monstrous. In the Milky Way, we have Sagittarius A star, a supermassive black hole with about 4 million solar masses that is calm and collected and just does its thing. We know it sits there because we can see a number of stars being thrown around by a seemingly empty spot. And despite its incredible mass, its radius is still only 17 times our Sun. Smaller than most giant stars, but millions of times more massive.